Okay, let's look at that limit as the delta y went to 0 again on that expression. So in class, what I said was, well, let's look at an example. And so suppose I want to look at y plus h. So we'll change this to an h goes to 0. And I said, well, let's use 2v dv. Okay, where I hadn't, it was lost in my notes that I'm going to divide this by h. So I'm going to put a 1 over h here. Now that changes the problem, but we'll see going back to the original that, well, no, actually it doesn't. So if we do this, then notice that this is v squared, so we get y plus h squared minus y squared over h. And, well, what we know then is if we take the limit as h goes to 0 of this thing, y plus h squared minus y squared over h, we're just going to get back the 2y, because we'll get y squared plus 2yh plus h squared minus y squared over h. Forgot my limit as h goes to 0. And of course the y squareds cancel, and so this is equal to the limit as h goes to 0 of h over h times the limit as h goes to 0 of 2y plus h. Well, that's 1 times 2y, and we get 2y. So in other words, you see we just get back the function that was in there. And so in the text, they had this integral. So we were looking at f of, let me find my notes now. We were looking at, if I keep saying that, I'll finally find my notes. Yes, looking at f of x given y, and we said, oh, that's the integral from minus infinity to infinity. Now, this part, though, let's take the limit as h goes to 0 of some y1 to, oops, and that didn't want to be infinity, that needed to be an x, y1 to some y1 plus h of our f of u and y dy, divided by the limit as h goes to 0 of the integral from y1 to y1 plus h of fy of y dy. Okay, so we have that. Now what we'll do without, and we'll not change the problem by tossing in a 1 over h up there and a 1 over h down here. And so you see, I haven't changed the problem. And now this 1 over h can go with this 1 over h can go with this, and that's how we end up with the fact that things didn't change. We just got back that function, and we just get back that function by taking that limit. And so we get minus infinity to x of f of u and y. Oops, forgot my dx up here. Du. And then divided by, I have to go down to the next page, our fy of y when we take that limit. Okay, so quick fix and all that, it just had to do with we needed to multiply top and bottom by 1 over h, and then when we take that limit, that's how we get to what's inside, and from our example we see how that worked. Okay, but we did need that to make it happen. Okay, but we can, since we had both top and that integral on the top and bottom, well, not the exact same integral, but those limits on both the top and bottom, we could do this on top and bottom and not change our problem. So that's how they got to this expression. All right, call that done.